Hello, and welcome everyone to another episode of Adventures in DevOps. I'm Warren Broad, your host, and unfortunately, Will not be joining us today. He'll be back next week when he returns from his vacation spot on the other side of the world. But today, I'd like to introduce from uh, more than 20 years in the industry, experience in platforms and consulting and advisory in many different areas. Uh, Work with the CNCF. With us today is David Stenglein.
Hello. Great to be here.
Yeah, thanks for joining us. Originally you said that we could talk anything about platforms. And this is actually a really interesting topic because a couple weeks ago, I had brought up that meeting with a bunch of DevOps folks experienced in the industry, we were actually trying to define what platforms actually are. Like what counts as a platform? And one of those conversations, the one of the co-authors from Team Topologies was suggesting that everything's a platform. And if everything's a platform, then I think there's this sort of fear that it's very difficult to define. Maybe it's sort of one of those things that I know it when I see it, but what it actually is can be difficult to identify in practice. What do you think?
Yeah, and I kind of get where the team topologies people are coming from, especially with their minimum viable platform, right? They define documentation as a minimum viable platform. But I think when we think about, and there are many different kinds of platforms, but we think about them a little differently over time, especially modern platforms. So I have a definition that is almost intentionally vague, uh, but it kind of encompasses a lot of things and helps kind of determine what they are. And that is that a platform is a system that allows you to build things and gives them a home, a place to run.
Oh,
Uh,
interesting.
and the other side of it is a platform either abstracts or completely captures work that the user of the platform would otherwise need to do. And that's it, because that is the basics of a platform, and it's kind of vague in general like that because there's a lot of commonalities between what we think of as like end user platforms, like an Uber or something like that, and internal platforms. Where it gets a little different is, whether or not you have like that network producer consumer, network effect type thing going on in internal platforms, and it can happen. But the reason I like this definition is I feel like I've been working on platforms for nearly 30 years. As an operating system as a platform. Does a modern developer even think about what the layout of blocks on disk is or how memory is managed for them, out of system? Like that to me is a platform. An operating system is something I can build and run on without having to worry about really low level stuff. But platforms kind of accrete over time, right? They get pushed down lower and lower. And like 20, 25, 30 years ago, we used to care a lot more about how processes were managed and how disks were laid out. And, there's only a very specialized few people who actually still care about that because we've built layers on top of it. So the definition of platform is a moving target over time. We expect more and more to get pushed down below us and to be able to work with higher and higher abstractions. So to say everything is a platform, I wouldn't necessarily say that. I do agree that a minimum viable platform or minimum viable set of tools could include just documentation for a small group of people. But when you get to a modern platform that is especially now being defined around self-service, right? Um, the criteria for it is a little different, and I think the distinction comes in between application and platform where it gets really fuzzy, right? So take Minecraft. Minecraft is a platform. You can build stuff and run on top of it, right? But another game like a multiplayer with no extensibility, well, that's an application. You might build much more, you know, high level conceptual things like clans or something like that on a game, but you don't get to build arbitrary things like you can in Minecraft, right? People built airplanes, computers. I think there's someone who wrote Doom to run inside of Minecraft, right? So, that's the proof of any sort of computer. Can it run Doom? And so if it can run Doom, maybe that's a definition I never thought of. If it can run Doom, it's a platform, right?
I mean, I think building on top of is an interesting way of looking at it because even at very slow processing speeds, you could make any sort of chat interface run Doom, right? So
Yeah.
I think I like that because it makes a distinction between we're running the thing and it's running on top of something else.
Yeah.
You did mention that you feel like the attention to some of the lower level platforms is not, we don't pay attention to it as much anymore. Is it because it's been highly optimized and there aren't a lot of further ways that we can take that? Or is it that there's now a lot of different layers, a lot of different abstractions that people are paying more and more attention to
It's because we
now?
can't, right? One of the earlier parts of platforms and computing was escaping assembly language, right? you know, and there are still people who work in assembly language, of course, but you can't manage higher and higher levels of abstraction while needing to know how to do everything at every level. I think it's important to understand how computers work, how the things work, but having the skill to work at all those levels doesn't really add up, right? So like when you call yourself a full stack developer, you're probably not writing assembly,
Yeah.
right? Because you couldn't maintain your ability to work on higher level problems and all that low level stuff, you wouldn't be very productive. So I think it's to some degree optimized because we've had a long time to figure out how to manage disks, how to manage memory. Linux is. I came from a background of Unix when it wasn't. Linux didn't even. I wouldn't say it didn't exist, but it was not allowed to be used in most sort of corporate environments. And
Yeah.
so we were managing like 5 different flavors of Unix systems, and now it's consolidated. And that level of abstraction to the operating system, right, is simplified. You don't have to figure out where awk is on like 5 different kinds of systems. Um, so that's almost a necessity for us to be able to move up to higher level things to build on top.
Yeah.
That even though they might be able to be optimized, we can't look at that. Now, the flip side of that is we tend to accrete things and get away from them and not optimize them. And we end up with our platform potentially being really bloated underneath us because we're not paying full attention to the cost of the abstraction that we're doing. Right. And so, there's a necessity to go through sometimes and figure out like those few people who understand go down through the layers and figure out, are we making the best use of this? Because hardware keeps getting so much faster, right? But yet we still manage to run at the same speed, right? So we're doing something in order to like add new stuff, but not make it more efficient. That, for all that we've increased, I found a SD card that was 256 megs the other day, right? You can get a terabyte SD card pretty easily now. And the fact that we were able to do so much in such constrained environments and get things done and responsive. And now we've added so much and we've got our Slack clients like crushing computers and adding up to responsiveness that is just still in the similar range, right?
Yeah.
So that's one of the risks of abstracting like that over time.
No, I mean, you said something about that, and actually, it sort of triggered me thinking if we add more levels of abstraction, can we still be in that situation where we understand enough about the stack in order to make optimizations? Like, I feel like I've heard a lot over my career, oh, but we still need to know how assembly is going to get built because there's optimizations that we could be making at higher levels if we know about that. And I feel like that's sort of eroded over time because the number of abstraction layers has definitely increased. I think there has been some return to that with like eBPF at the networking level, like sort of, okay, there are optimizations here, or there are things that we need to know. at the lower levels inside the operating system, and when we have multiple platforms on top of it, it's very difficult to see that. But like you said, assembly, I mean, it even goes lower. Like people aren't going to know exactly how to stack the silicon to make the transistor.
Well, yeah, and maybe some of those layers will need to go away. Like I think WASM will have a big impact on the intermediate layers. Like I think
Yeah.
you're going to see a whole lot wiped out once. It's going to take a few more years, but once you have WASI components, so for that's a good acronym. Stop, right? WASM is called WebAssembly, and it's essentially an instruction set that allows browsers or originally browsers to run sort of arbitrary code as opposed to specific HTML and JavaScript and type stuff. So you can compile. Used to be you had to target C code, compiled code at a specific architecture and run it on that specific architecture. And WASM allows you to compile C code or other code that you normally targets real machines to run on a web browser or a Node JS backend. It's been around for a while, and people have been waiting for it to kind of become more prevalent. And it's been slow to develop, but I think, a good way. They're being considered because there have been a lot of provisional standards of things that get partially released, and then you end up with lots of incompatible implementations of things. So it's good that if they're building a universal format for running code, that they take their time. And one of the big advancements that they've had recently is having high level an interface definition language with high level types between WASM modules. So you'll be able to have a runtime with Python, Rust, C code all interoperating with each other through the WASM runtime using high level types and not needing all those languages to know directly how to talk to each other or embed or the things like that. So all of the composition stuff that we do now in order to create software, either making stubs for specific language runtimes or using even containers, right? And saying, oh, I need a sidecar, I need another complete copy of Linux with its own libraries and all this other stuff, when really I just want this HTTP server with this specific kind of way of working. That sort of thing, that complexity will go away. And the WASM runtime will actually run HTTP between components with no network involved. So you'll get down to nanosecond latencies for making HTTP calls between components. They'll all be in the same runtime, and you will eliminate all of that network and operating system stuff that allows us to do composition now. And so I think it'll add its own complexities, right? But it will also eliminate a whole layer of stuff that we're dealing with now to build software, which is I have to deal with a whole lot of operating system stuff and Docker and all this other understanding, when I'd like to just be working in terms of higher level application tools. And so I think that kind of compaction is what we get over time. So we figure out this set of platform layers, we're working with this now, but it may not become part of the permanent strata underneath us because it hasn't proven itself, and we're going to go some other direction and maybe eliminate that layer, try an alternative, and then eventually, like Linux became, the sort of standard operating system substrate, right? And it took a long time to get that consolidated and sort of decided as an industry.
No, I totally get that. I mean, it makes a lot of sense actually if you're thinking about where the future of a particular component is going. And this isn't the first time I've heard WebAssembly. I think it's been brought up on a lot of teams I've led in the last decade. And it's always been it's still too early in a way to have these modules built and then running, even if you're using the website. And historically, there weren't bindings available. But the idea that, okay, we're trying to figure out where the top of the pyramid is, where the actual application, where the actual value is, and the interoperability between modules that could be built in any language and then run only at runtime, proves, okay, we sort of figured out a success path here. Now let's get rid of all the CRUD that doesn't directly deliver that execution platform, and focus on that, rebuild it, rebuild what the browser is offering potentially, and get to the point where we can deliver the application on top of it.
Yeah, one of the sort of byproducts of WebAssembly that's been kind of useful already and probably increase is the access to the GPU
Hmm.
from WebAssembly is starting to become standardized,
Okay.
which means that writing code to talk to the GPU gets drastically simpler. So like right now, in order to talk to a GPU, you need you need the library specific to that GPU. You need a lot of libraries. You need a lot of code. And now it's becoming easier to just write some Rust code that uses the GPU in a fairly compact way without requiring, a half a gig or a gig of library downloads in order to get to it. So, that was done before AI was really prevalent, but like it's already sort of yielding some dividends in terms of simplifying being able to run and that you could think of that as a platform. Like that platform stack for running AI tools is enormous,
Yeah.
but people have been working on sort of compacting it down. Like the Mozilla Foundation has they call it llama file, and it is a single binary solution for running a local LLM. And it's essentially a very fancy self-extracting shell script with a bunch of zips in it and a new kind of libc that will run same 4 gig binary, includes all the model weights and the binaries to run on Windows, Mac OS, Linux, ARM, and x86. So you just download this thing, make it executable, and run it wherever you are. And suddenly you have, Olama running, or sorry, OpenLlama. All of these things are named so similarly, right? It's
Of
like
course.
all some play on Llama. Olama is another system for running local LLMs that's not related, and they kind of make it easy, but they go through that gig download of just libraries. So like that's another like platform stack that's just going to like get squashed. And right now, understanding what's going on in terms of at least the software platform, really difficult, right? But if you can squash down those layers into, I just need, you know, we're in that kind of turbulent situation of extreme innovation where everyone's just utilizing things from everywhere else. And then in a few years, it'll settle down and it'll be a little easier to understand what's going on because it'll standardize and it'll be a much slimmer way of getting things done.
I mean, that seems like a great foresight there. Like, I think everyone knows that the fads are going to end at some point, and there's going to be what is left, the actual innovation. But that puts a name on it, right? It's that we are searching for the optimal usage here, and when someone figures it out, all those other things will go away, and we're actually seeing this sort of play out
It's
much
happening
faster.
right now. Yeah.
Yeah, right, for sure. And I think there's a huge speed component as well, because unlike WebAssembly and the layers that came before it, which I want to say are things like infrastructure as code, especially in the DevOps space, there's a lot of companies putting a huge amount of financial capital behind quickly investing it, hoping to both be the first and also most successful, getting whatever it is, user percentage numbers. So, any thoughts like when this
So
is gonna?
I do. I think there's a hype curve, right? Um, and I wrote a blog post about it recently because I kept the industry is just constantly one hype cycle after another. And, part of the Gartner hype cycle is it looks like this, and then it goes like there's that trough of disillusionment, and then it climbs into a slope of, what do they call it? The plateau of productivity or something like that, right? And there are some hype cycles which don't seem to result in a plateau of productivity. They just seem to come through like a wave, but then drop back down again, and not everyone catches it. And I think microservices are an example of that. There's in larger, slower moving organizations, microservices have not really had that much benefit and potentially even been detrimental. like had almost the opposite effect of making systems far more complex and just as slow, and maybe even more dangerous than the previous legacy systems that were there. If you contrast that with something like big data, big data is like the lifeblood of so many companies now, and it and the difference between those two things, if you look at it, is business value, right? Big data was easy to translate into business value. Microservices is just a technical solution to things. And there can be business value to it, but it didn't originate necessarily there. And it was to solve an engineering problem and an organizational, a socio-technical issue. And that ability to move fast, I think, ends up being important, but sometimes overplayed. So it's especially weird in a time like now when we have AI making everything move so much faster, that there's this like big gap opening up between large and small players, to the point where it's been, we're 18 months, little like maybe 20 months in, and the big players are trying to keep up, and they're adopting things that are already legacy, right? So LangChain took so much mind share early on, and then they got a hold out of the ThoughtWorks radar, right? One of the few things on the recently published radar that was actually a hold, and it just it probably hit it right at the point where a lot of companies were finally ready to start like adopting tools like that. And so like all of this continuous disruption and figuring out has a natural cost to it. And I think everyone wants to move fast, but they're going to end up wasting quite a bit in order to figure that out. And I think the companies that are more experimental with that, rather than saying, oh, we're going to define the standard and go, it's not a time to define standards. It's a time to experiment and figure out what works and learn more nimble approaches to business, right? Because there's still plenty of companies that don't know how to experiment. They only know, let's put it through a bureaucratic process that gets us something to work with in 18 months.
For those that are generically moving slower and aren't interested in defining the space or even experimenting, is this the sort of thing where there's a lot of value in waiting it out, hopefully seeing where the leaders are, and either, I don't know, purchasing them through acquisitions or buying their products or partnering with them going forward? Or is there still room everywhere for companies that are invested in technology in some way to also be experimenting?
I think there are ways to experiment. I think banking on things is a little tough right now. And there's an old saying, I wish I could attribute it, but encouraging people to use boring technology, right? Because it gets dangerous, and it is an important bit with platforms. If you throw too many sort of modern or non-commodity things into your platform, you're going to end up with potentially a lot of parts that don't mesh very well together. And the experience of the users of your platform, both your internal and if external users depend on it working well, might not be good. So you have to make a trade-off of I'm going to go for modern things for part of this because they are still bespoke and new parts of that I can't get anywhere else. But for these other things like the 80%, right, I should be going for commodity items and not overburden myself with too many new things at the same time. So yeah, there's plenty to be gained for, ML and AI have been around for a long time, right? It's everyone wants to make it the core of everything, but if you take a somewhat more experimental approach and figure out where are the areas I could use it that are truly differentiating for my business, as opposed to like a lot of executives are looking at AI as a cost savings, right? And it's certainly not at the point of being that. It's a first mover advantage, not a cost savings right now. And when it's a first mover advantage, that is almost like the opposite of being a cost saver. Those are people who are willing to put money into things in order to gain an advantage. There's a story from Simon Wardley about the beginning of cloud and how the cloud vendors were selling, um, corporations and such as, adopting cloud will save you money, right? And the first company to decide to use the cloud to accelerate basically threw that out the window because everyone else had to use the cloud to accelerate and therefore not save money, right? So the same kinds of things play out with AI. Using AI to save money will only work if everyone decides to do it that way. If someone uses it to accelerate past you, well, you're probably going to be forced to do the same thing.
Yeah, that's for sure the case. I mean, I remember thinking about when AWS came out, it wasn't for everyone in a way. It was, oh, look at all these companies that are maybe in startup land where the tools they had were not really that effective, and we would just take all of that work, all of the capital expenditures that they would need to purchase physical machines, data centers, etc., and just immediately eliminate it. And for sure, there is a capital expenditure sort of savings there, cost savings, but realistically, for sure, it's on the speed side.
Yeah.
To,
And that, AWS and cloud providers are mashing, they are platforms. They've grown in scope to where they're not always the best self-service platform for your internal developers. And they did originally try and sort of pitch that, but it gets messy really fast. Um, but they did bring the whole concept of self-service IT and computing to the fore. And what they did is they eliminated all that human in the loop stuff that people in IT had traditionally, like, I want to set up an app. All right, I got to talk to procurement and get the hardware. I've got to get a team that will set it up for me. I will get another team to set up other stuff on top. And like you go through this whole process, whereas they made it, all right, you make an API call and we'll give you a database, right? And you don't have to go through months and many different teams. So that aspect of platforms has kind of been trained in from an early point in cloud. I think the difficulty is translating that between what cloud providers are sort of able to do and what organizations need to do either on top or beside that to provide a similar level of experience that is like specialized to what that organization needs. And the people working on the cloud providers, they're all developers. They're used to building end-to-end systems that work as systems, whereas IT people are not developers. Like systems people glue things together. They don't build, rock solid solutions that they can present as an API to people. And that's been some of the gap of platforms being adopted internally, is that, it's been a phase of adapting to, oh, I need to build a rock solid product now. I can't just make this one narrow automation of some specific task. I need to make something other people can build on. That's a very different approach to things than what IT is traditionally used to. So it's taken time for that to filter out. And then you have vendors flooding into the space to try and make this easier for people to do and kind of build that product mindset as a product. But if you don't have the mindset of building products to begin with, you can misuse tools. I mean, the same thing happens with all of our other like sort of microservices and cloud. If you keep the wrong mindset, you'll just do data center in the cloud. If you keep the wrong mindset with microservices, you'll just make a giant distributed monolith. If you go and keep an old IT mindset with platforms, maybe you're going to require a ticket submitted, right, that you use the platform on behalf of the user to create. So, there's a continual like change in how we do things, but we tend to carry some of our existing ways of getting things done forward that is not usually pretty healthy.
Yeah, for sure. That's a pretty good insight, I think. I mean, while we're talking about it, and so you know, you've nailed the web browser is for sure a platform for running code for all modules of all kind, especially through WebAssembly, cloud, AI. Are there, if we say there are platforms everywhere, are there other prominent areas of tech that sort of encompass this that you know are constantly on your mind? Or, you know, these are the big three.
So I think the thing that doesn't get as much attention is the actual uh, we call them internal developer platforms, but what we mean are portals to platforms in most cases, right? But until WASM becomes really widespread, I still think we have the issue of what is the environment that the developer actually works in and builds and runs in. And there's a giant stack in there that I don't think gets quite enough attention because a lot of the platform thinking happens from the system side
Yeah.
and not always the developer side. So systems people think, well, once I get Tomcat installed, you're good, right? Or once I get the OS installed, you'll install Tomcat and then you're good. And Tomcat or whatever, or Node or whatever environment is just a very base layer. And we've been trying to accommodate them with more and more of the pipes with meshes and stuff like that. But there is a whole aspect of building applications that could benefit from platforms in terms of, well, I need to talk to a database. How about I talk to it in a standardized way that's appropriate for my organization and what our local standards are and how we've architected for talking to databases. And that bit is kind of not as, doesn't get as much attention because it always feels like some of these, evolutions or revolutions always get pushed from one side of the house, right? And therefore, there isn't necessarily this kind of balanced view. So I think there are plenty of areas like that in the, data. I've had a few people ask, is a data system a platform? Like, of course it is, but they don't, they feel hesitant to bring it up because they don't feel, I'm not sure why. Like, it's easy to build stuff on top of data platforms and therefore call it a platform. But there's this perception that if it's not Kubernetes, it's not a platform, right? And that's one of the things I think is a bit difficult, is the idea that like platforms have to look a certain way rather than be a mindset about something for people to build on.
No, for sure. I mean, I think that makes a lot of sense realistically. I'm just getting stuck on the if it's not Kubernetes, it's not a platform. I mean, I think the answer here is there were platforms before, and there's got to be platforms like after that. Otherwise, the word sort of doesn't have a lot of meaning. It's just
Yeah.
an alternative
Yeah.
for that.
Yeah. And it really, so I am involved in the CNCF working group for platforms. And I've been a little hesitant to get involved with the CNCF because their definition of cloud native is containers and Kubernetes,
Yeah.
right? And my definition of cloud native goes well longer in history than that. Like I'm more like the 12-factor app type cloud native, right? And the nice thing has been is the working group for platforms has been very open-minded in terms of what a platform is defined as and what is important about a platform. And it has not been about Kubernetes specifically. So I think there is some movement towards figuring out what cloud native platforms look like without it being completely bound to Kubernetes. Because I think everyone says the cloud native is built on containers, but like I said, WASM could throw that completely out the window within 5 years or so. So making yourself completely dependent on a container development environment, workflow, and mindset for building distributed applications might not be the best approach. So, I mean, it's good for the CNCF because they're so heavily invested in a Kubernetes-based ecosystem with a few other things possible. But I like that the working group for platforms is more open-minded than that. And we're focused on making good habits and hygiene around how you work with people in an organization to decide, what should we build and how do we deliver value better. So their maturity model, which got published right around KubeCon Chicago last fall, it doesn't mention tech stacks, right? And there is some eagerness for technical content from this working group, but I believe it has to be delivered in such a way as to not. It needs to be sort of like, a cloud provider has like you read the documentation, there'll be tabs for each language and SDK you could use to. I think that's sort of the way we need to go about it in terms of providing, not a specific reference implementation, but here's an approach you could take using 2 or 3 different options for making your platform code testable or something like that, right? And rather than picking a specific test kitchen for Terraforms, like show them a few different options and give them the mindset that they need to get into.
I mean, I think that's a really interesting point. Containers took us a very far distance, and so thank you to Docker for that. We got the OCI out, the full initiative, and now it is for sure an open standard. But you brought up a point earlier on where that's not even really what you want to have to run or deploy, right? You may just want the HTTP interface, and you still have to sort of decide, okay, what's my base image? Where does that come from? You're really still just building on top of operating system or other technology, and no one for sure actually really cares about that. And now we've got, someone does. Like, I don't want to throw that out.
Someone does. But I think there was I think in some ways Docker took us a long way, but it also took us backwards too.
Interesting.
Because there was a move to application paths like Cloud Foundry, which is just sort of like an installable version of like a Heroku that did a lot of, really looked at concerns from the engineer's perspective, like, people building systems as opposed to platforms. And it took a lot into account for them and really focused, it's very user focused. And we went a little backwards because of, there were some issues with running a platform that way and that level of abstraction. We kind of decided, we didn't want that level of abstraction in that way, but also there's a lot of cost and licensing involved in the decision to sort of back off to something like Kubernetes. And then organizations find out that they're giving up all of these PaaS style features. And suddenly, like, I know of one organization that's figured out, we went over to Kubernetes and we didn't realize that like every app deployed in Cloud Foundry got a managed RabbitMQ, right? And they didn't have to think about messaging for their app. And suddenly we moved them to Kubernetes and we're forcing all these teams to figure out how to run hundreds of instances of, a queuing system. So I think there's been a little bit of a back step that wasn't even necessary in some cases. Like, for instance, take build packs. Build packs are wonderful for not caring about, the container stuff down below. But it's possible to use them with containers, but nobody does. Same organization that's on Cloud Foundry, for some reason, instead of figuring out build packs on Kubernetes, just went with making everyone produce Docker files, right? And so like all of that work invested in making their apps run as build packs needed to be, pretty much redone in order to run on Kubernetes. So I do appreciate some of the stuff that we got out of Docker. Like, I come from that, like I said, that time of, figuring out how to package up software on several different it's still an issue on Linux, how to package and distribute software. Docker does so much for that, but it's a lower level than we need to be for people to be productive building applications and business value.
I sort of want to dive into that because there seems like a really interesting corollary here between what you want out of uh, the application layer that you're building and maybe some of the things that the YAML file in the pod for Kubernetes offers. Like I can think about, what does an application actually need? What would you prefer Docker to have provided? Would it be like the HTTP interface, the message bus? Like you just hook into standard strategies for that. You don't have to know what the implementation is. Is that what you're thinking?
Yeah, exactly. Like if I'm building an application, I want abstractions. I want to build, I'm going to build a diagram,
Yeah.
a logical diagram of an application, and it will have, connections that are logical between components, and not I have to do this apt-get install of this thing and wire it up. And there is a certain bit where developers don't understand those things, sometimes don't want to. So they don't understand basics of like how network data moves, right? And ports and firewalls and
DNS.
but there's like I said earlier, there's a difference between knowing about those things
Yeah.
and being forced to deal with them, right? So I think there's far too much in a Helm chart or a Docker file that we force developers to understand and deal with, as opposed to figuring out how to, ease the way. And there's a lot, I think there is a fair bit of work being done on that. But again, we keep pushing it from the system side, right? A lot of platform DevOps, a lot of that stuff gets pushed from the system side. And we keep saying, well, we want you to work in this format. We're going to make it easier. And the developers are like, it's really complex. Like there are a lot of developers who are really into it because it's exciting, right? But at the same time, many of them just want to be able to figure out how to build what their job is telling them to build, and not take all these like side trips to figure out on Stack Overflow, like, how do I get this like Docker Compose to work or something like that. So yeah, it's part of that is like the whole shift left idea,
Yeah.
which puts too much on people on the left, right? The idea of getting earlier in the process is good, but there's something else that came up, and I don't know where it came from, but we had a platform coffee before KubeCon EU in the mornings, and someone brought up shift down. So certain things should be shifted left and made a concern, like, testing. We've always had this idea that, separate QA team and everything. And there is a fair bit of the functionality of testing that should be done on the left.
Yeah,
But figuring out test frameworks and all of the plumbing and mechanics and practices, that shouldn't get all shifted left. That should get shifted down. And you still need a quality engineering team. They're just not black box testing anymore. They're responsible for a different set of things that offload, as we've shifted load over to the devs by shifting left. Now let's figure out how to offload some more of it again and put that on a team that has a product that takes care of aspects of your testing.
I thought for sure you were going to say platform because the testers there are building maybe a platform for testing so that you can make it easier to pull those things in during the development cycle rather than having to be worried about each and every one of them.
So there's another definition of platforms that I came up with a while back, and sort of defining what they look like. And to me, a platform is a set of runtime environments and pipelines connecting them, and then frameworks to interface with those two things. So, you might have a QA framework or a testing framework that allows you to drop testing into your pipelines. You might have a discovery API or something like that allows your app to function in the runtime environment, right? So I think that some of these things are actual platforms, and some of them are a little more distinct in terms of being frameworks to allow you to do things, and you're kind of building on the framework, but it's not actually the place where it runs, right? And so, like, think of maybe the build and pipeline systems as the platform, and then other people, giving you frameworks to make it easier to run on those platforms.
I like this definition. It makes it much clearer that there's specific things that people could align with rather than maybe some more abstract ideas, and the fact everything is be called a platform. So it's the pipeline and the interface for it, and whether like some level of abstraction, whether it's HTTP, TCP, or a full SDK or framework to interact with it. And what was the third piece?
A runtime environment.
And the environment to actually execute. Yeah, for sure. That makes a lot of sense realistically. And if it doesn't have all of that, it's marketing nonsense.
Yeah, yeah, and that's why I like the whole idea of Backstage and other things as internal developer platforms. I I don't get the developer platform thing. Your system is built on some sort of platform that needs to accommodate all of that stuff, the runtime and so, I think it's more appropriate to call things like Backstage portals
Yeah.
that interface to the platforms, right? But and it also leads to this. Well, there are some people who still don't quite get that when we say developer platform, we mean the platform for, and they're doing DevOps. Because everyone's thinking, oh, it's platform post DevOps. No, to me, it's the evolution of DevOps to the point where people can focus on their lane, right? My lane is to build business value in the form of applications. I shouldn't have to consider how blocks are stored on disk or buckets are managed in AWS or, those sorts of things, right? And it allows me to do DevOps for my application, not DevOps for patching vulnerabilities in the operating system or, like we were kind of forcing people to do in earlier forms of like total freedom DevOps, but, you're also totally responsible DevOps, right?
I mean, I think it's a UX problem here, and maybe UX from a product standpoint, where, as you said, it's being pushed from the system side rather than, if I really don't want to know about that stuff, there should be what I like to call sensible defaults.
Mm-hmm.
That I don't have to pick something; it does give me the right block store and the right file system, and I don't have to know the difference between NTFS and EXT and etc. in order to actually even deploy my thing. Give me something that sort of works, and if I say, wait, the IOPS read and write to my disk is this slow, is that reasonable? And then maybe I want to investigate and choose the options available rather
Yep.
than having to decide that up front.
Yeah, and you want to be able to define your storage needs because you understand your storage needs in terms of maybe TPS, right?
Mm.
And that, and if you spend a little time at the work and you understand the application that you're building, you say, oh, if I'm trying to clear through, 1,000 transactions of JSON of this like, oh, I need a disk that performs like this. And you can say to your platform, I have this storage requirement,
Here are my
space
needs.
and speed and latency potentially, right? And then maybe it can help you by saying, oh, you fall into this class, right? And that's one of the differentiators in terms of platforms is I feel like Amazon and others, they're general purpose platforms. They're just the kitchen sink, right? You can build anything you want. What organizations need are opinionated platforms built on top of those with all those sensible defaults and guardrails. And it's not just sensible defaults, it's sometimes just the inability to set things that are just not appropriate for you, right? You should not be setting security related things. That's set for you and you have no way to override it. And that encapsulates a whole bunch of things that make life easier for everyone. The idea of like maintaining security, auditing, controls and compliance. Like if you take that approach of people stay in their lane and it's not so easy for them to break out of it, then, we have a lot more control over the environment with a trade-off in cost. Like Do you maintain speed and flexibility? Right? And again, this is like where the pendulum swings is sometimes those controls and security and compliance end up taking on too much weight. And the people trying to produce things on a platform end up suffering because, well, we put all these safeguards in without figuring out with you what you need to do to get your job done. And that's that product and user centric aspect of platforms, as opposed that needs to be there to differentiate from how IT used to work, which is we build it, you will use it.
Yeah, no, I mean, I think you still sort of see that problem with the user experience from an innovation standpoint. If the users who are building the applications on top of your platform don't have any way to give you feedback on where they're getting slowed down or what they could use, what their actual needs are, then you have this sort of issue where the innovation can only come from those that are building a platform. And they, of course, don't have the actual use case of building an application on top of it. And I've been struggling with this for a while now, and I'm not sure there is like a clean answer. I mean, if you have the best perfect platform ever, developer platform, then there's not really an issue. But how do you make real headway in how to change your platform and make it better if you aren't sort of dog fooding it yourself?
Um, there is an option that's kind of in between because it's difficult to get systems people to dog food the
Yeah.
platforms entirely because A, they don't historically work like the typical SDLC developer cycle, and B, the work that they do is difficult to have work that way. So a good engineering life cycle, testing, mostly unit test. You've got the test pyramid, mostly unit tests at the bottom, then you step up to integration, functional, and unfortunately, the way that systems people are required to work with cloud providers, it's very difficult for them to do lots of unit testing at the base. They end up getting stuck with integration. So it's immediately like a barrier to them like changing the way they behave in the same way that their users do. But they could go and talk to their users
Yeah.
and they could shadow their users and they could spend time seeing how they work, even if they don't work the same way, and just spend the time to listen and understand and figure out if what they're building actually solves a problem for the user, as opposed to what's traditional IT is they're solving a problem for themselves. Like they have requests coming in, they need to automate in order to be able to survive the rate of requests.
Yeah, for sure.
And that's not what you know, and the issue with like being built from one side is it's a massive loss in efficiency and a huge amount of cost. Say you build 8 features
Yeah.
in your platform and only 3 of them are useful. Like the developer, like you guessed right, for 3 out of the 8. That means you spent time on 5 things that you have to maintain, that you spent time building that are not solving problems. So like they don't get as much effective change in their ability to get value delivered. You spent lots of time doing stuff that people didn't need. And it ends up being a big cycle of waste, right? Because we're not startups. We're not startups that are looking for product market fit. We're not trying to figure out what customers want because we don't, it's a captive audience internally. You can just go talk to all of them. So you don't have the same constraints as a startup where you need to imagine what your users will find useful. You just go ask them, right? And then that allows you to prioritize what's going to be the most useful. Unfortunately, IT has never functioned that way, right? Or at least only partially ever gotten there. So in order for platforms to be really successful and for all this speed to happen, you have to figure out exactly not come up with solution first, which is how, I mean, it's how I remember my boss coming to me as like, oh, we're doing annual planning, need to figure out the budget. What should we build for next year? Right? Like what's and it's just not, let's go find out what users need and solve their problems.
It's way more fun that way, right? These things seem fun. Let's go and deliver it. I think 5 out of 8 or 3 out of 8 success, 5 out of 8 failure. I think that's a great rate. Like everyone should be proud if they actually got 3 out of 8 features
Yeah,
correct
that's
there.
true. That's true. Instead, what you get are entire platforms that are just not useful, right?
Uh,
And no adoption and become legacy, before ever being born,
I
right?
mean, I think you're lucky if you get no adoption. I've seen this sinkhole of there is one team using it who
Oh
has
yeah,
a lot
yeah,
of
yeah. That's
money,
to
and
maintain it forever, right?
yeah,
You
right.
built this big overblown thing, and you only got partial adoption, and now you've just added to the stable of platforms you have to basically maintain forever because you never hit a solution that gets the clear adoption.
Which could actually have a negative impact in the organization if what you're actually providing is like automation of ticket, solves, right? And those aren't the things that people necessarily want. Actually, I think there's a huge trouble here in trying to actually identify what the value is or quantify for the platform or for the features that you're adding there. And so, because you can't do that very effectively, it's even more difficult to remove things and prove that that would be a problem for someone. Uh,
And
I
that's
pick your bait from that.
that that's where you get into at least a product mindset. And I hesitate to say product management because
Yeah.
then people start to think they need to hire product managers. And that's not necessary or even realistic. Like we go through these hype cycles where like DevOps or SRE or everyone starts to think, oh, I need to create a job description and hire a few hundred people that fit that and put them on teams and we'll be set, right? And that's not realistic through any of these cycles. It's never been realistic. And so if we focus on a product mindset of finding out user pain points, figuring out what the problems are, what to solve. What I think you can get to is also if you're getting closer to how value is produced, you can actually start to draw a connection between the things you're doing and the value being produced because you're having an impact on the engineers that are directly producing the value. So, in a way, you're indirectly contributing to the same value. Whereas if you've just got a flow of tickets and you're just trying to make the system more reliable because you're in the way of things, like you're seen as a traditional cost center, right? We're trying to minimize your participation here because like it seems like you just break things or you're only around to fix broken things. Whereas if you're solving pain points and you're making people work faster, that's contribution to value, right? So I think that the again, the mindset of focusing on users and their pain points and potentially pulling that in, especially sentiment about that in, is how you start to get to measuring. For instance, I know of a company where someone created went to QCon conferences, 5, 6 years ago, started to see talk about platforms and DevOps and this kind of developer productivity type stuff
Yeah.
and started what amounted to a platform team. Instead of measuring things like Dora, they just measured for subjective things like developer satisfaction. And they managed to go and, as a byproduct, fix all of the, like their Dora metrics, which they didn't track, went up, but they knew they were doing dozens of deploys a day instead of once every month, right? So, which is more important? People's ability to feel productive and get their work done when they're working directly on business value. And then the byproduct being, well, that value flows faster, or focusing on the thing that is potentially gameable, which is just a number, right? Like a Dora metric for deploy rate or things like that. I think those are signals of the system, not terribly useful in terms of measuring value.
I mean, there is this mantra of any metric that becomes the target ceases to be a good metric here. And I think the developer fulfillment is sort of interesting. I used to think that Dora metrics were well weighted to make it very hard to game in a way in which if you were to game them, at least you would be doing something better than likely you are doing today. But now I've started to see them for sure being gamed in ways which were not intended and have negative consequences, like throwing feature flags in everywhere so that you can just get your code into production without actually having it tested, without it having incident appeal, without users actually seeing the code, and then
Yeah.
saying, "Oh, my Dora metric for cycle time is now low." Congrats, right? You just eliminated the metric's value, and you threw all the work and all the tracking into a metric that you're not even paying attention to, which is uh, sort of released to cycle time for the feature flag being enabled.
Yeah.
So I'm
And
gonna,
you've created a game. So where I think Dora is appropriate, it's a system level signal that leadership should be using to figure out what they're doing wrong.
yeah,
And that's not how, I mean, most places are looking at commit rates and things like that and talking to people about it instead of reflecting on why does my organization have trouble, trending these Dora metrics in the right direction? And because, way companies are traditionally managed, it's always some sort of performance. That's why there's all this like developer performance measurement and stuff like that. It's like, I can't possibly, have anything other than like a problem with a team or a person, or like as soon as I fix that, like GEs, let's lay off the bottom 10% every year, like just fire them, and that will make everything better, right? And I think more and more servant leaders are coming into existence who understand that they have to build systems in which people can be successful, right? And Dora metrics are one of many things that you could use as a signal to understand, are you building a successful system? Sentiment, also very good. And I find it interesting that like Forsgren, who was involved with Dora, moved on to space, which is, more subjective, much broader. And then you've got DX, which is just this triangle of not really unmeasurable, but far more user experience focused,
right,
right?
right. No, I mean it brings me to ask, and I think maybe with DX in space, maybe that's the answer. Is there a go-to metric for you, or is it, at least from my experience, it's like let me take a inventory of what the current situation is and see where there are opportunities for improvement, which push something along in some way which I unblocks, or you look at the obstacles or something like that. But it feels very subjective. Like I see people getting stuck, or I see communication failing in some way here. Let's work on improving the communication, or the collaboration, or unifying the thousands of platforms we're using down to only a handful. Is there any sort of concrete metric that you more tend to like? I mean, it's all perfect, right?
I think from a technology perspective, you should be looking at things like SLOs that are inherently outward facing and relatively difficult to gain, and kind of make you part of an ecosystem. And because there's two sides to those sorts of metrics. There's like, okay, this is what our objective is. If we're not meeting the objective, and it doesn't match up with what the sentiment is in terms of user satisfaction, it kind of like puts some tension there into having the right kinds of numbers. Um, and but at the same time, I don't think I think metrics get overused and also stay around for too long. There should be trends and things, and that you should identify parts of the system that require attention for periods of time. Find your constraints, exploit them, remove them, and then work on to other things. So in terms of like systems, metrics are useful for diagnosing, right? And they're not great to just watch all the time. Like you want lots of data about how your system is functioning, but you should be looking at composite trends. You really should be business level things, right? Should be a combination of employee satisfaction, customer satisfaction, financial performance, right? If those things are in balance, almost nothing else matters, right? So, those are the things I would go for, but that's almost like I wouldn't call it a pipe dream. Most organizations are really far from understanding that, because technology doesn't communicate in business terms. And I've said this many times, technologists are almost allergic to where their paycheck comes from. And I say that, it was funny, I got contradicted on that once, uh, in that I think in startup land, people are fairly well connected to where their paycheck comes from. In big enterprise, they have no idea. In both cases, they find it very difficult to communicate with the business and get them to understand the value of what they're doing and that sort of thing. So it's I don't think there is one easy metric. What I'd like to see start happening is better communication with the rest of the business and the ability to align on these sort of fundamentals. Because if you do that, you can get people to work on the most valuable thing because you'll have a straighter line toward, and this can go very deep in the organization too. And maybe allow the organization to make decisions about buy versus build. Like, why are we spending so much of our human, capital on this thing, which is like a commodity and, not paying for itself? And I'm very careful with that because I also believe in the fact that you have, your humans are the most valuable thing, and simply treating them as resources to be added to or removed as part of your costs just seems foolish, right? So again, it's like a systems level thing, signals for how leadership is doing.
I was I had this fear you were going to say ENPS score. I mean, for what I don't particularly like it. I think there is this uh, surveys not done well give you the wrong signals, and I think it's
Hmm.
very challenging to be able to effectively actually grasp, is there fulfillment on the engineering side? Are our customers actually happy? I mean, I think so. Here's one idea that we need to look out into the future in order to actually evaluate that. But then on the flip side, I think, oh wait, no, actually companies are still bad even correctly evaluating where they're currently at, let alone being able to correctly evaluate
Yep.
it
Yep.
down the line. The interesting thing with the SLO is the service level objective is that it's still it's very subjective in nature, right? It's not like your SLA is what you put in your contract, and your SLI is the thing that you can actually measure what is happening. But the SLO is like, we want this, and
Yep.
where does
And our
that come from?
customers want this. We
Right,
know our
exactly.
customers want this, right? But going back to the ENPS thing, um, I think that one of the mistakes I've seen is that if you're going to survey employees about their satisfaction or things like that, you need to have a like you can't make your employee survey different every time you give it to them, right? It doesn't give you a signal, right? So and I think that happens with a lot of metrics is that you'll see like a KPI board and all you'll see is the absolute numbers for the current time period with no trends. And like, how am I supposed to, like, I have to contextually understand the value of this absolute,
Yeah.
and for many businesses, they can get that, right? But if you don't know the trend, what's the value of this thing, right? It should just be a binary, a binary switch at that point. Um, and so ENPS, I think, yes, it's difficult to figure out, but what I think is more important is the trend in those things, and deciding if you can tune it at all by making changes. The actual answers, other than like a subjective rating, might be difficult to interpret. But I think you could tell with an ENPS, like if you are going to make changes to a company, if it's going up or down, maybe you're having an impact or not, right?
Yeah, I mean, I've seen this done. It's one of those things that I've only ever seen done poorly, and I'm still waiting for that circumstance where it's like, oh, we did it and it worked out great. I think there's the teams change too frequently. There are too many changes in the organization, not like from an individual standpoint, to actually accurately be able to trend that information over time. There's this knowledge that assuming the questions aren't bad, which they're usually bad in some way,
Hmm.
uh, you're looking at the data, and as a survey answerer, you're filling that out, and the result is often, wait, I know what there's like a quote unquote right answer here, and if I answer negatively, I know what's like, I fear what's going to come next. There's going to be a conversation I don't want to have. And worst case, I do answer negatively and then nothing happens.
Yeah, yeah, and that's a lot of what the approach is of people doing the surveying. Like, why are you surveying? Are you again doing it from a like you're doing some sensing?
Yeah,
What was your reasoning for doing that?
for
And
sure.
are you trying to figure out reactively how people are feeling, and therefore say something different in the next town hall, right? Or are you actually interested in delivering change that addresses what is you keep scratching deeper with and I think ENPS, well, a small teams very difficult like that. Any team under a certain size, and I wouldn't say what that is arbitrarily, that isn't ENPS is like doesn't have value, right? It doesn't have a there's a statistical minimum, right, for things like that to have value. um, and if you're above a certain point, I really think it should just be like a 1 to 10, right? It shouldn't be a survey. It should be something easy to get sensing and feedback on. And I've seen places where they even have like a kiosk and people just, you know, bounce the numbers as they go through, like the bathroom ratings that they
Yeah,
have in
airports. Yeah. That's
let's
that's
put
usually
those
what
up.
I've seen. Or yeah, no, I mean that's for sure true. I think the problem with the 1 to 10 in a past life, we had some surveys in this area. We were focused on improving leadership and getting feedback around that, and oh, we had a SaaS tool and everything, and that didn't work out because it turns out that some people are notoriously bad at even knowing where they're at personally, right? They say something's an issue, but it really wouldn't affect them. Like, oh yeah, I would leave if we throw Kubernetes into our platform. But then you do it and they don't leave. It's like, oh, well, I'll leave if I have to do manual testing and I'll have to be responsible for testing, shift left security, shift left, everything. Then they don't leave, right? So I think that's always been sort of a struggle there. I like the
Yeah,
message.
yeah, and that's an interpersonal, and that's and again, that's also size, right? I mean,
Yeah,
sentiment
for
is
sure.
something you could, when you say true sentiment, that should be a statistical thing. If you're dealing with a small group, you're not getting sentiment, you're getting like opinions,
Yeah, an average
or
version of those opinions, right?
yeah, and that's a trickier thing. And, I used to think that platforms were, and the kind of consulting I do, which is advise people on how to get started with platforms, evaluate what they need. Um, we didn't even get to cognitive load, for instance, which is, I think, a big I wouldn't say misunderstood, but underutilized way of looking at platforms and how organizations function, and at the organizational level. Because I think there's a lot of emphasis on reducing cognitive load of developers. And, that doesn't work well if you just shove all that cognitive load somewhere else in the organization. So you really need to have in an internal platform situation, you need to look at the distribution of cognitive load and make sure that it's kind of even, right? When you're building a SaaS for external customers, the amount you're reducing their cognitive load for some problem. The amount that you take on really just has to do with your ability to be profitable and take on. You could take on any amount of pain as long as you can be profitable for it, right? But with an internal platform, if you do that with your platform, you're just going to create bottlenecks because there is no, with the platform team, there is no P&L ultimately. Some people would like to think that way, but there isn't in the same way that you get with an external platform. So yeah.
I'm hearing the message should be there needs to be P&L for any team building a platform internally. Uh,
Oh, I
I
hope
mean,
I didn't say that.
no, for sure not. I mean, I have thought about this in the past, and there are some things with chargebacks that some organizations have tried. I think there's an interesting aspect here. The perfect market out in the world when you're selling to customers is realistically you want the marginal value to like go to zero, like the amount you're getting you're wasting or spending on building your thing is exactly how much customers are paying for it. If there's not, then either you're charging too much, hypothetically. Now, of course, you want to do that because then your business makes money and you can pay people, etc.
Hmm.
But internally, I do see without that there is this sort of lack of balance. The internal teams end up probably in deficit, right? They don't get that feedback. So there's
Yep.
no measure for, oh, you only have this much money coming in that we can support it. And they just keep adding features, as you said. But now I'm wondering whether or not we need to be focusing on cognitive load more, and if there's a way to directly calculate that, because you could figure out, oh, this much cognitive load we're reducing from the organization, and this is how much cognitive load we're centralizing in this other area or in this team. Their cognitive load is going to increase over time, and you
And
could
you're
try
going
to
to
look at those.
bottleneck.
Yeah, for sure.
Yeah.
Is there a like?
Well,
Have
there
you?
isn't. Well, I've actually been working on something like a cognitive load map of an
Okay.
organization. So, giving you the ability to visualize how cognitive load is distributed and combining that sort of like with the network of interactions that happen and figuring out if you can make it assignable. So, assignable cognitive load. Can I assign it to the nature of work that I do? Can I assign it to some other team that I interact with? Can I assign it to how I'm like, and start coming up with a way of kind of rating this? And then you should be able to get, what sort of looks like a heat map. And if it's really out of balance, it should be really clear. And you should be working to try and like even out that heat map. And so, I think the team topologies focuses on at the team level, doing a cognitive load assessment to figure out like when they're overloaded and when you might need a split in a team. I actually also think we need to jump up and look at the whole organization and figure out how much flow are we trying to force through. Like take features. You mentioned features. Like what are we doing about features? Like features just tend to go up forever, especially for internal things. Like when are you going to remove features? When are you going to control the flow of features so that you're not overloading the whole system?
Yeah.
And a cognitive load map could help, visualize what's going on in a given organization and figure out, is it running really hot somewhere? And does that correlate to, some other things you could do like value stream mapping and seeing like, how is your value actually flowing? And oh, if it tickles this one, point in the stream that seems always be slow, oh, and it happens to map to some team that's really red, right, in the map. There's maybe a constraint I can work on. And I think platforms, and I think I heard this on the podcast you just published. Look, at people tend to go big bang, right? It's been forever. IT initiatives have always been like massive undertakings, and you need to focus on experiments. You need to focus on iterative value generation, right? And Big Bang is not about that. So that's another product mindset thing. Focus on your users, focus on the value you could get to them quickly, and figure out how you're going to measure whether or not that was a success. Do they feel any better about getting their work done, right? And there's all sorts of tools for assessing that. There's a model from NASA. So and we'll get into cognitive load for a minute. Cognitive load is uh, a model for talking about learning. So there are three components to it, and I don't think we have time to go into it in any real depth, but it is primarily concerned with people's ability to learn new things. And so it doesn't map perfectly over to platforms. There's some sort of gaps with how that works. NASA came up with a model called mental workload that took into account cognitive load, but also physical conditions, time constraints, things like that. They actually have a tool for surveying teams on this, and it can kind of give you a better idea of they would use it with astronauts and say, oh, we gave you this problem to solve. Your spaceship is about to fall out of the sky, and how did you feel about solving that problem, right?
Wow.
And that I think those kinds of signals could be really useful in figuring out if you're actually solving problems for teams.
No, I mean it's such an interesting topic, and I really wish we had more time. So maybe this is a part two.
Part two, yeah,
David
yeah.
comes back and tells us how to calculate cognitive load and do it effectively in organizations. So there is something that we always do on this podcast, which is picks.
Hey, you promised there was no.
I know. I joked with Will early on that this is actually the struggle for me to come up with one of these, and that I have to come up with one every single week. So that's
Oh wow.
52 a year, and I just don't have that many things to go through. So grasping at straws there. But I'll go first. So my pick of the week is going to be The Fifth Discipline by Peter Senge, which actually dives into how to think about systems thinking, how to apply it in organizations, how to apply it in situations. This is an introductory topic to systems thinking and systems engineering and how to apply it. And I think it's something that a lot of engineers would really find beneficial, like how to actually think about organization in sort of a technical way and help us justify when to build platforms and what does that actually do to the organization. What problems will that actually solve longer down the line? And it's something that I find is missing very frequently.
I there's a bunch of things there's a one of the problems that we have with platforms and technologies is listening skills. Everyone in technology is really eager to jump to solutioning. They'll hear the beginnings of a problem and they'll just start thinking solutions. So the ability to generate more ideas and be flexible about ideas is important. And there's an interesting book, Adam Grant, that I'm listening to. I haven't even finished, called Originals. And
Yeah.
it talks about how creative people just produce more. And they're not necessarily as self-critical. They're not necessarily good at judging what success is like.
Yeah.
There's some other stuff in the book about how to figure out that success. So I think that there's a lot about interpersonal interactions and psychological safety and factors like that that are far more important. I guess my pick, and I'm always pitching this one, is actually a podcast called The Hidden Brain.
Okay.
It has given me so much insight into the counterintuitive ways that our brains work.
Okay.
We tend to assume one thing, and it's very frequently different from what we think, and that has a lot of impact about how we behave in organizational settings, especially. So I would highly recommend The Hidden Brain. Is if you enjoy psychology or at all, or you'd like to know more about yourself.
I
Sorry if
think it's a
that
great book.
was seemingly off topic compared to
No,
your.
no, you know what? I actually had picked this before, and then you kept going into systems engineering. I'm like, wow, he's like selling my pick for me. No, I mean, I like the hidden brain. I think we could get there realistically because those sorts of things affect our judgments, affect where we focus on
Yeah,
building. So I think that's highly relevant as well. No, I mean, you can for our
and I
picks,
took
you
two
can.
picks.
Yeah, that's fine. That's also fine. You're allowed to have two picks. I like originals. I think it is a great book by Adam Grant as well. So, okay, so that's it for today. Thank
Awesome.
you, David Stenglein, for coming on and sharing your wisdom with us. It'd be really great to have you back on the show in the
Yeah,
future. So,
we go all the way down into cognitive load.
yeah, definitely,
Really
we should
cool.
do it. Okay, so
All
thank
right.
you, everyone. Thank you, viewers. And we'll be back next week with Will.
Thanks
And
for having me.
yeah, of course. And let me stop the stream.